All right, now let's start. 2.5 has to do with equations of absolute value. Just a quick review. I took this from a different textbook. What in the world is absolute value by definition? I think you guys know this. This is for Math 61. But when you talk about absolute value, what you're really talking about is the distance from that number to 0. Or you can say from 0 to that number. So we say the absolute value of 5 is 5 because the distance from 5 to 0 is 5. The absolute value of negative 3 is positive 3 because the distance from negative 3 to 0 or from 0 to negative 3 is 3. We're good? And so with that, we begin a little bit more here. And the book sort of dives into problems here already. So as we set it into an equation, what do we do here? Start off easy. We'll work our way to more complicated problems here. Let you quickly write it down. Alright, so absolute value of x is equal to 6. What do we know of this here? If you sort of think about it, what's the possibilities for x? Yeah, x could be either a positive 6, right? Or x could either be a negative 6. So notice what we do here. We keep this x alone, and what we do here is we actually just change the sign on this one, right? Because this part here could be, could either be a negative or a positive. Okay. Good there. That's exactly the same concept we're going to apply over here. This one's a little more complicated, but still the same thing here. How about this? We say 2x plus 1 is equal to a positive 11, just like we did with this one. Or 2x plus 1 is equal to a negative 11. We good there? Okay, there's one little math trick that I'm doing that I'm not showing you, so let's talk about it so you guys don't get confused. It's not so much that the 11 changes places, and again, the reason why I wrote this down first is because that's the way the book does it. But I want you guys to see the math behind it just real quick. The math behind it is this. It's not so much that the 11 is either positive or negative, it's the 2x plus 1 is positive or negative. We're good? So let me do it the correct mathematical way, and then we'll do it this way here, just so you see it. Okay, so that means the 2x plus 1, that itself could either be positive. Good there? It's a positive statement. So notice this is going to change into this right away, right? Or it could be that 2x plus 1 is actually a negative. Good there? So what changed from here to here? Hey, we technically either multiplied through by a negative or we divided by a negative 1. We good? So that's kind of what we were doing here. Doesn't really affect it when it's an equal sign. It will affect stuff if it's an inequality. So got to think about that. That's why we're going to switch the sign on the inequality later. So anyways, that's the real mathematics behind it. This is what we do as a little slight shortcut. I think we're ready. Can you guys solve each of those? So let's see. Subtract 1 from both sides. How about a 2x is equal to 10 divided by 2? And I got x equals 5. Good there. On the other side, if you subtract 1 from a negative 11, you get a negative 12. So ooh, a little different there. And a negative 6 for your answer. The way the book writes the answers are like this. And some algebra textbooks always have the lower number first. So they'll say negative 6 comma 5. It doesn't matter, because these they're called braces or sets. Doesn't matter what order they're in, but that's the way you'll see it in the back of the book. Okay, of course we've got to do stuff with fractions as well, so here it is. And another little slight change. Again, this is sort of one of each type happening here. Alright, so notice one little extra piece now. Notice that little minus 1 right over here. Alright, so notice that little -1 over here. We can't do anything until the absolute value is all by itself on one side of the equal sign. So no changing anything. The absolute value has to be by itself, or else we can't even do the problem. Okay, once you get to that point, now let's do it. So 2 over 5x plus 7 is equal to a positive 3, or 2 over 5x plus 7 is equal to a -3. And I'll let you guys try and finish this off yourself. Give you a little bit more time here. See a few people still waiting. All right. You have some options here. I don't know which way you guys did it here. You could have just multiplied by 5 everywhere here first. And that's fine too. You could also subtract 7 first. It doesn't matter which way you went. I subtracted the 7, then multiplied by 5 on both sides. So got myself a -20. Divide by 2 gives me a -10. Are we good there with that one? On the other side, subtract 7. If you do that, you get yourself a -10. So when multiplying through with the 5, now you get yourself a -50. Or remember, the quick way to do this is just to multiply through by the reciprocal. Remember that? Multiply by 5 and divide by 2. Over here, same thing. Multiply by 5, divide by 2. Again, just a little bit easier, a little faster. There's your dividing, and hopefully you guys got that as well. Alright, state your answer in set notation and you'll be done. So I should have braces, -10, -25. It doesn't matter what order as long as you have both answers. And again, very quick lecture. I'm really just giving you one of each type really quick. This one was the fact that the absolute value was not by itself on one side. We had to move things over to make it, and then we could split them off. Okay, the next one. What happens if the absolute value is equal to a negative number? All right, don't do it yet. Let's try it here. So let's see. Remember how absolute value makes everything positive? Well, it's saying absolute value of this is equal to -5. Is that even possible? Because this guy is always going to be a positive number. Is that right? So can a positive number ever equal a -5? I don't think so. So this only works. So we just write no solution. This only works. Absolute value, you can only split them off two different pieces if they're equal to a positive number or 0. Doesn't work any other way. So you'll see about 2 or 3 of those on the homework. All right, the next type. Again, kind of going quickly here. What happens if you have two absolute values equal to each other? before we start the problem here. So notice, here's what we got here. This could either be positive or negative, and this could either be positive or negative. So we actually have 4 different cases, don't we? We have this being positive, this being positive. We have this being positive, this being negative. Then we have this negative, this positive. Then we have this negative, this negative. Whew. Okay. Used to love torturing my high school kids because I used to make them do all 4 cases. Do the positive, positive, the negative, positive, positive, negative, and negative, negative. Until one of the students would finally come out, Mr. H, you know what? If you have a positive, positive, or if you have a negative, negative, they always come up to the same answer. How come? So if this is a negative, this is a negative, and we divide through by negatives, what do you get? Hey, you get the positive, positive case. We're good? Or if this is a negative, that's a positive, we divide through by a negative, you get this now being the negative, this being the positive. So there's still only 2 cases here. Still you got, and you got to just designate which one you want to be the positive. So here's the positive, positive case. Or actually you can call it the negative, negative case, right? Or, and again, just make one of them to be a negative here. So negative of x plus 2. I won't torture you. We're good. I'll just tell you that that's the way it is. All right, then all yours to finish it off. Cool. All right, I'm going to try it as well here. So let's move the x over to one side. I got x plus 1 is equal to 2. Subtract 1, subtract 1. Everybody okay with x equals 1? Cool. Okay. This one, got to multiply through. This is a distributive property, which you guys probably know here. So negative of x, negative of 2 gives you negative x minus 2. And then have to work it from here. So adding x to both sides. 3x plus 1 is equal to negative 2. Let's see what we got here. Subtract 1 from both sides gives you negative 3. Divide by 3 gives you a negative 1. And the question comes up, Mr. H, do you always get opposites? No, you don't. That's just kind of the way things worked out. Not necessarily get opposite answers here. So negative 1 and positive 1 should be your answers in little squiggly marks. And you're good to go there. Okay, that was the easy one. A little bit more complicated with 2 absolute values equal to each other. I'll let you guys try it yourself though. So let you guys try this one first, see what you guys get. Alright, and yes, you should get a no solution somewhere in there sometime. Then you also should end up with a fraction on the other side somewhere. If you got that, quite possibly have the correct answer here. So let's go for it here. So again, absolute value equal to absolute value, both positive or one of them being negative. Alright, in this case, let's see, when I subtract x, we've got a little problem because my variables just disappeared on me. And if that's the case, 3 does not equal negative 6. And I got myself a no solution for this one. But that's okay, because I still could get an answer here somewhere. So distribute the negative. So how about a negative x plus 6 this time? Alright, and adding x to both sides gives me a 2x, looks like, plus 3 equal to 6. Minus 3 from both sides gives you a 3, divide by 2, and eventually how about a 3/2? And as we mentioned before, in algebra, we like improper fractions. We keep it as 3/2. No need to change it to 1 1/2, and that would be the final answer. All right, end of 2.5. Moving on to 2.6. We're going to change it up just a little bit. We're going to change it to inequality. What happens if you have absolute value, but now instead of having an equal sign, now it has a inequality behind it, a less than or equal to, a less than or greater than or equal to symbol. Well, we got ourselves a little problem, because in the previous section, 2.5, when we used to solve something like this, that was easy. We used to get individual points, and you could just list them as x equals -7 and x equals +7. Here we got ourselves some problems here. Whenever you talk about absolute value being less than some kind of number, what you're really saying is, I want to go away from this number here, in the sense 0 this time. I'm going away from it, but I don't want to go too far. 5 is the most I can go away from this number in the middle. So I can go both directions, and if you think about it, this is an AND statement. Those of you that did your homework from the previous sections, notice, yeah, this is an AND statement. So we're going to treat any less than or equal to symbol as an AND statement. Going back over here, this one's a little different. If you're saying, I want the number to be bigger than or equal to 4, what you really are saying is you want the distance away from 0 to be either 4 or bigger. But notice it can go different directions, right? Because 5 would work, 6 would work. Or it could go this way too, right? -5, -6. So notice this is an OR statement. So real quickly here, less than or equal to, there would be an AND statement. And this is the short way to write AND. We'll see how that works. If you see an absolute value is greater than or equal to some kind of number, that's going to be an OR statement. So let's do some algebra. This was just sort of to explain it. Algebraically, this is what we do right here. This was probably the one that you want to write down. This is what we did in 2.5. And here we go. Absolute value of something less than C. Whenever we see this, we're going to change it into an AND statement, which looks like this. And again, from the previous slide, you can kind of tell, oh yeah, that's right. That's set up. If you have a greater than symbol, what you have is you have an OR statement on your hands. All right, this first one with the equal sign, that's a 2.5. But here's 2.6. If you have other stuff inside here that's less than C, what we do is we put a -C on the other side, put less than symbols, and what you're really saying is you're saying this expression is caught between a -C and a +C. If it's a greater than symbol, then you got to do the OR statement because it's going off in two different directions. Okay, well, let's go for it here. Easy one to start off with, and we'll work our way up. I'll wait just a little bit here. See a few people still writing it down. Go for it. I think we're good. Okay, let's go for it here. So we got the absolute value of 3x minus 1 is less than 8. Cool. And again, the first question out of your mind should be, is this an AND statement or an OR statement? Looking back at our notes here on the previous slide, it's an AND statement, huh? We take the 8. What we do is we take the 8, we put it all the way in front, and we make it into a negative 8. Less than symbol comes down, and whatever's inside the absolute value comes down without the absolute value. Then we'll make it less than positive 8. So it's the negative of this right here on this side. All right, if you remember from the previous class, this is just a short way to write AND. I'll do it the long way over here, just so you can kind of see how that works after we finish this off. But I think we had practice with these here. What should we do first?
Add the 1 to both sides.
Perfect, yep. Add the 1 to, in fact, all 3 sides, right? You add the 1 here, then you have to add the 1 over here, and then you have to add the 1 all the way on this side as well. So we're working on 3 sides at a time. Cool. All right, negative 8 plus 1 makes negative 7. Now we're just left with a 3x there. Looks like we're going to divide by 3 here, so we've got to divide by 3 here and here. So working on all 3 sides. And once you solve this, the good thing about solving it this way, which is called the short notation for AND, you know exactly your starting point, you know exactly your ending point, and you're done. So can we graph this? Absolutely. Let's put a graph together here on the bottom. Negative 7/3 is going to be right here. Positive 3 is over here. And again, short notation for AND, so easy. The question for you guys is parentheses or brackets? I got parentheses, right? Less than symbol. And notice also, you don't, remember how last time when you had only one variable, you'd go the same direction as the inequality? You got to be careful here, because you're saying that negative 7/3 is less than the number that I want. The number that I want is less than 3. So kind of careful what that means. If you're caught between 2 less than symbols, you're saying I want the stuff in the middle. Okay, that's short notation for AND. Let me do it the long way, just for you guys to see it. Let's see if we wind up with the same answer here. So, the long way, if you want to write it down, that's fine. This being positive, or, sorry, and the other possibility is that being negative, right? We talked about it. This is the one that changes. So what we do here, we divide through by -1. Everything else remains the same. Hey, so notice that little inequality switching right here. That's important there. Okay, let's keep on going here. So +1 + 1, there's my 9. Divide by 3, there's my 3. Add 1 over here, add 1 over here, there's my -7. Divide by 3, and there's what I got here. Okay, so I want to change this into this right here. So how does that work? And again, don't need to sort of learn it because we know the shorthand notation. Real quick here, if x is greater than -7/3, tell me if you guys agree. If that's the case, isn't this also true then? That -7/3 is less than x. Good. If you switch the numbers around, you got to switch the inequality as well. All right, and if that's the case, notice this part right here is right over here, and x less than 3 is right here as well. So we just combine the x's together as one big piece here. So all we do is we just write it like this. And if that's the case, then I can write the shorthand combining the x's together as that piece right there. Okay, which way's faster, first way or second way? Okay, that's why they do it this way here, because it's a whole bunch faster. You don't need to do this at the end, change this around, put an AND statement, and then write it over. It's just all in one complete package. Okay, so I'll let you guys try the next one by yourself from beginning to end. It's number 2, right over here. Should not give you the answer here. At number 2, we just did one. This one is absolute value of 2x plus 5 is less than or equal to 13. Just received another email. All right, let me start it as well here. It's almost done. So I look at this here. It's an AND statement because of the less than or equal to symbol. I take the 13, make it into a negative, less than or equal to 2x plus 5, drop the absolute value, and make it less than or equal to positive 13 again, because it's easy way to do it. All right, subtract 5, subtract 5, subtract 5 everywhere. That gets me a negative 18 over here. How about a positive 8 over here? Even better. Divide by 2 everywhere, and voila, got my answer right away. All right, and then can you graph it? In the previous textbooks, they actually made you figure out where 0 is. Your textbook doesn't. It just says, okay, plop down -9 where you think it is, plop down a 4. The only thing is brackets or parentheses. This time it's brackets because it's less than or equal to. That little piece equal to means I want the -9 as part of my answer. I want the positive 4 as part of my answer, and I want everything in between. All right, that's the AND statement. Hopefully we got good enough practice with you here. Turning around, giving you the OR statement now. All right, the OR statement has no short notation, so can't really do what we did with AND. So we got to do it the long way here. So just like we did before, it is x minus 7 is greater than 5, or, and again, here we go, x minus 7 is less than -5. Why do we switch the inequality? Because technically, remember, we're dividing through, but with a -1 over here. All right, let you guys finish that off, and then can you graph it? All right, not too much work here to be done. So just adding 7 to both sides gives me x is greater than 12, or Adding 7 over here gets me an x is less than positive 2. Alright, with this one, again, it's an or statement. So the 2 is going to be the lower one, 12 will be the higher one. Brackets or parentheses? Parentheses. And this one right here, x is less than 2. What we're saying is we're going to go parentheses and we're going to go off to the left. So make the arrow humongously bigger. Because what you're saying by that arrow is you're saying it's going to keep on going to the left forever. Technically, if you don't make the arrow bigger, you're saying it stops somewhere. And it doesn't. It keeps on going. Alright, with the 12, again, a parenthesis as well, but this time going off to the right-hand side. So how about an arrow and goes forever. Okay, I don't know why I did not write this down here. So let's do it together here. I'll step on the slide a little bit. Okay, with this one, they also want to give you the final answer. Like, what is the answer here? So what we have to do is we have to write an interval notation. So in this case, what we're going to say, just like in the previous section, remember that in 2.4, I think we did that before, the interval notation. You're saying negative infinity to 2, and since we have a little gap in the middle here, we're going to say this. Then we're going to have to say 12, and then off to positive infinity. Alright, with the next one, I'm going to skip that part right there. Let's go on to here. Okay, all yours here from beginning to end. Can you solve it? Can you graph it? And then also, can you give it to me in interval notation? This is your practice item here. Alright, give you little hints here. If you got a 2 somewhere there and you got a 2/5, you're doing good. Alright, let me start it as well. If you are completely lost, look at the board, but I'm sure most of you guys are doing okay here. So the positive case or the negative case. Switch the inequality and then take the opposite of the 4. Solving this one, adding 6 to both sides gives you a 10. Dividing by 5 gives you x is greater than or equal to 2. Adding 6 on this side gives you a 2, and then divide by 5 gives you a fraction of 2/5. And again, making the graph here. 2 is over here, 2/5 would be less than that. And then going with a bracket right off to the right. Making the arrow bigger. Bracket off to the left, making the arrow bigger as well. Okay, now can you answer it in interval notation? Alright, let me try. So how about negative infinity? 2/5. This time we need a bracket because of that right there. So bracket union. We also then need a bracket at 2 and then going off to positive infinity eventually. Alright, on the homework, part of the homework it just says solve it and graph it. Part of the homework says solve, graph, and put it into interval notation. So just depending what problem you're doing, what section you're on in the work. On the exam, what I'll do is I'll have it both as a graph as well as interval notation. So I'll have both of those. Alright, I think you've seen something like that before. I'll give you a hint here. What happens if the absolute value is not all by itself? Got to do a little bit more work there. Alright, hopefully you guys got it here. Since the absolute value is all not by itself, we have to make it all by itself. So we have to add 2 to both sides. And now we can proceed. We had to do that first. And or again? Cool. Alright, got 2 people answering out of a class of 42. So yes, it is an and statement, so all yours from there. Alright, let me go ahead and keep on going here. So, and statement, there's a shortcut way of writing it. There it is. Put the -7 on the other side. And then just work on all 3 sides at the same time. So how about a -3 here, a -3 here, and a -3 here. So a -10, a 4x in the middle now, and a 4 on that side. Divide through by 4. Leaves us with a -5/2 is less than x is less than 1. Alright, out of just curiosity here, show of hands if you guys got to that point already before I showed the answer. Okay, about 40% of the class. Okay, alright, graphing it. Looks like -2, -5/2 is going to be on the left side here, and the 1's going to be on the right. And brackets or parentheses? Parentheses this time. Okay, again, it's an and statement, so that means it goes towards each other, and it's all the stuff that's in the middle. So the number that we want is in between. Writing this in interval notation. What would that look like? And again, very similar to the graph. It would be a -5/2, comma, 1. Interval notation and the graph are very, very similar. Okay, with that, Now let's start. Number 6. All right, let me start it here. Hopefully you realize it is an OR statement, first of all, because of the greater than symbol. So then it's whatever side the absolute value is greater than 15, or 6 minus 3x is less than negative 15. Hopefully we went to that, or else the whole entire thing will be wrong. And the signs wouldn't make sense if you did it the other way. All right, with this one here, subtracting 6 from both sides. Another thing that comes up is dividing through by negative 3. And again, big humongous alarm goes off in your head, is that right? Dividing through by negative. What we have to do is we have to switch the inequality around. And we got ourselves x is less than negative 3. On the other side, same thing happens here. Subtract 6 from both sides gets you a negative 21. Divide through by a negative 3. You have to switch that inequality around. So I got myself x is greater than 7. Go for it. I see a few people with erasers jamming. I'll wait up just a little bit for you guys. Alright, so graphing this here, negative 3 over here, 7 on the other side, it's going to be a parenthesis going off to the left. X greater than 7 is going to be a parenthesis going off to the right. And again, can you write it in interval notation again? So we got ourselves a negative 3. Oh, just kidding. Alright, how about this here? We got ourselves a negative infinity, because it goes off to the left, to negative 3. Because there's a break there, there's union 7 off to positive infinity. All right, and then we got to handle two weird ones here. So this one is the weird one. And what makes it weird? Yeah, you got yourself a negative 2 over here. With absolute value, we only think about positive stuff. So the question here is this. Since this is always going to be a positive number, the question really is this always true or never true? Positive number being less than -2? I don't think so, no way. So 0 with a slash through it. Think about it before you do it because of that -8. So let's go for it again. That absolute value is always going to be a positive number. Technically it's a positive number or 0, but we think about it as positive numbers here. So never true or always true. This time it's always true, huh? Yep, this is always true. So therefore we have something called all real numbers. So that means it works for every single number on the number line. If I take a number, like say -10, -10 times 7 is -70, -70 plus 6 is a -64, but when I take the absolute value of it, it's still going to be bigger than the -8. Good there? So I could take humongous negative numbers, positive numbers, it doesn't matter. It's always going to be true for that right there. All right, and the graph of this line, it would just be the whole entire number line filled in. We good? On the previous slide, if it was no solution, that means you just have a number line, but it's empty. There's nothing drawn in it whatsoever. It's just an empty number line.